Okay, working on the law of signs note packet for the law of signs. And so the law of signs relates the ratio of the opposite to hypotenuse ratio for a triangle will have the same relationship throughout every side of the triangle. So the sine, the opposite over hypotenuse for sine A over the length of the side A will be the same as the sine for B over side B in that triangle. And then if you want to do the reciprocals of these, you can flip the over and they will also be the same. So this is a great rule that helps us find missing sides and missing angles from a triangle. And so we know that the angles of a triangle always add to 180 degrees, which of course is the same as pi, but we'll be working with degrees in this unit. Then we have the area formula, and this is derived from the law of signs, that if you think about your area of a triangle, we always think of it as 1/2 base times height. And so this formula can find the height of a non-right triangle. So we can find the 1/2 base times height for a non-right triangle using this, and this is just 3 versions. The idea being that if you have 2 sides, if you get the angle that they form, you can find the area using that. Okay, when can we use law of signs to determine a triangle and to solve for all the angles and all the sides? We can use law of signs if we have angle, side, angle. We can use it for angle, side, angle, and those will determine one triangle, and that's because they are congruency rules from geometry class. Those prove congruency. Now this case right here, the SSA case, is also called the ambiguous case. This one is not a congruency rule, but it can still be used in law of signs. However, we don't know until we go through and do the work. We will not know if it's going to be 0 triangles, 1 triangle, or 2 triangles. And if we find that it's 2 triangles, we won't know which one is right. Which is correct. So in that situation, we will have to report both triangles. So that happens occasionally. And so let's go on to the next page where we will look at why we have an ambiguous case when we have a side angle case. What makes it the ambiguous case? So if I think about this triangle that's being described here, it has points A, B, C, and they said that side AC is 10 centimeters long. So why don't I just put on my paper, if you were here in class, I would have you take out a ruler, take out a compass, and then you could mark that with a ruler, you could mark something 10 centimeters long. And then I told you that angle A is supposed to be 30 degrees. So I would have you take out your protractor and measure 30 degrees, and I just have you draw that line going out for a long, long way, and now we know that this is 30 degrees. Because we don't know how long that line's going to be. We don't know. But we do know that side segment BC is going to be 6 centimeters long. So if we think about this is approximately 6 centimeters long, if I swing an arc from there, if I swing with my compass, I swing an arc, I can see that I have 2 locations where I am hitting the side A, B. I don't know if B was at this location or if B was at this location. I don't know that information. I do know that that arc that I swung was 6 centimeters and this original line was 10 centimeters. So that forms two separate triangles, and I don't know which of the triangles was the correct triangle. The triangle that actually most people would think it is, and it's kind of counterintuitive, is actually this bigger triangle. This is the one that most people would stop if they were doing an ambiguous case with cosine. That's because this angle being the acute angle, that's the first triangle that you would have found using law of sines. But the one that seems when you draw it more obvious is this triangle, the red triangle. So we don't know if our triangle was this triangle, A, B, C, with a 10 and a 6, and we don't know what that angle is. Or was it the bigger one that looks wider, which actually has an acute angle up here at angle B, and so we don't know which one it is. So that's why we would have to report both of those triangles, because we don't know which one was the right triangle. We'd need to have more information. So let's first start with a case that only has one triangle, and so we will find our one triangle. It's not an ambiguous case. First thing I always do is draw my triangle. I don't need it to be to scale, I just need a drawing. So I've got A, B, and C. I know angle B is 28 degrees. Angle A is 18 degrees. Side B is 100 feet. This is not an ambiguous case because I have an angle, side, or a side, angle situation of congruency measure. And I can tell that because I don't know this, and I don't know this, and I don't know this. So if I'm naming it, I don't want to jump over two unknown things. I want to go either from this way or the other way as I go through. Don't jump over two unknown things. So this one I can solve, and it's going to be only one triangle because I'm not going to use an inverse sine to get the angle. I'm using the rule of 180 degrees. So angle C will be 180 degrees minus the 28 minus the 18. I can say that angle C is 134 degrees. So maybe my drawing wasn't that great, but it's fine. And if you want to redraw it, you can with the 134 if you want it to look more like what this triangle looks like. But it's not really necessary. So, okay. Now I'm going to try to get my sides that are missing. I know that I know everything about angle B. So I want to use a B over sine B relationship. I'm putting the unknown length in the numerator just because it'll make it easier for me to solve. And let's go for side A first. So I'm going to set up, you only pick two lengths, two angles to relate to each other. I'm going with A and B. So 100 over sine of 28 equals, I don't know A, that's what I'm finding, sine of 18 degrees. So multiply both sides by sine of 18. And I get that A is equal to 100 times the sine of 18 degrees divided by the sine of 28 degrees. And if I want to make sure that I close my parentheses, so why don't I punch that in the calculator just to show you one, and then from then on, I probably won't have to punch it in. 100. Oh, I didn't check my mode, but we'll see if the answer comes out. Sine of 18 degrees divided by, see how I had to close those parentheses, sine of 28 degrees. That one I don't really need to close. And I get 65.822. I'm going to write down to the thousandths place, and if I need it for any calculations, I'm going to use that. Otherwise, my answer is 65.8. But for my purpose of my problem, I'll probably just be using the 65.8. Okay, now let's find side C. So side C over the sine of C will be related to my B. I'm going to stick with B because I know everything about B. So C over sine of 134 degrees equals, B was 100, sine of 28 degrees. So now multiplying both sides by sine of 134, dividing by sine of 28. It's always a good idea to pause things, see if you can find the answer. 153.223 feet. So really side A, I'm going to call it 65.8. I'm going to call side C 153.2. I found the angle C, which was the unknown angle of 134 degrees, and that means I have now solved my triangle because the other information was there. Now I need to find the area. So for the area, you want to use two sides in the included angle. If I'm using this angle B, I'm using two sides that I found and an angle. If I use angle C, I'm using one side that I found with a side that I knew, but I had to find the angle. I think angle A along with side B would be my best bet, especially because right now on my calculator, side C is on my calculator. So I would say that is probably the best location to go with. So my area will be 1/2, and I'm going to be using angle A. So I need side B, side C, and the sine of angle A. So 1/2 B was 100. C was 153.223. Notice how I'm using the long decimal, sine of 18 degrees. And when I punch that in the calculator, probably actually would just use the answer key from my calculator to do that. I get 2367.4 dot 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 dot. So let's just call that 2,367 feet squared. Realistically, you probably could round that to the 10th and call it 2,370, and that would probably be a little bit more reasonable because since you didn't have that many significant digits going in. So that one's done. Next page. First step, draw a triangle. This is an 140-degree angle at angle B. Side C is 20 feet. Side B is 40 feet. As I look at this triangle, knowing that I don't know, it looks like I have a angle side also known as a side-side angle, ambiguous case. So that means that there's a possibility of 0, 1, or 2 triangles. So we'll have to watch out on this one. So looks like I know everything about B. I am going to try for angle C. So sine of C over side C will be related to sine of B over side B. Sine of C over 20 will equal sine of B, which is 140, over, those are degrees, over 40. Sine of C is equal to 20 sine of 140 over 40. Sine of C is equal to, let's see what that number is. Punching that in the calculator, 0.3213938048. I'm just writing a lot of digits. That's the ratio of the opposite to hypotenuse for the angle at C. If it was a right triangle, of course. I want to find angle C, so I'm doing inverse sine. And when we think about how when we do an inverse sine, there are 2 places where you can get positive answers. In quadrant 1, you get answers from 0 to 90, not inclusive, and then in quadrant 2, you get answers from 90 to 180. And that's the thing, is that in a triangle, these could be your obtuse triangles, and these could be an acute angle in a triangle. So this triangle has an obtuse angle at B, so clearly it can't have 2 obtuse angles. So the second quadrant answer, I'm expecting it not to work. However, we're going to give it a try and see if it'll work. So triangle 1, that's looking at quadrant 1. What would be the angle C, which is the inverse sine of that very long number? And I get an angle of 18.747 degrees. Now I can get angle A. Angle A. I'm going to finish the entire triangle before I think about my other triangle. I will finish my entire triangle, 180, subtract the 140 degree, that is angle B, 18.747, and I think angle A is 21.25 degrees. Now I need to look at side A. That's going to be across from A. So side A over the sine of A will be equal to, and because I know everything about B, I'm going to use B, 40 over sine of 140. This B 40 to sine of 140 relationship will be true throughout this particular triangle. Oh, and I could have put what A is in. And so that gives me a side A of 22.6 feet. So now I have my side A. I'm just going to write over here that this, I would have probably been a good idea to just put that angle A in there. I have determined angle A, and I have determined angle C. I have determined everything about my first triangle. Now I just want to go back and decide if there really was only one triangle, and just to verify that, let's look. I do know that there is not a second triangle, but if there had been a triangle 2, I would go back to the calculation of my angle when I did my angle C equals inverse sine of 0.32139 of 18.747. That now is my reference angle, which I need to then put in quadrant 2. So quadrant 2, for a reference angle of 18.7 degrees, angle C in my second triangle would be 180 minus 18.747. My angle C in the second triangle would be the obtuse angle of 181.3 degrees. But that does not work with angle B equal to 140 degrees. Together, that is too much because triangles have 180 degrees total. So that tells me that this is a one triangle case. So even though it's not a congruency shortcut, I actually was able to find the true triangle, the only one triangle that will work for that situation. Now I need its area. So back to my triangle, I think my best bet would be to go with the angle B, because that would give me the most information. I have my two sides and their included angle. So I will go with angle B, and that will give me sine B as my, when I do my area, I'll go 1/2 AC sine of B. So 1/2 A, which is 22.6 dot dot dot, I'd use it long, times 20, 20, 20. Erase that and fix that. 20. Sine of 140. Make sure you enter it in one long calculation, 144.993. Let's call that 145. What's the units? Feet. Area is squared. Your mini quiz will be a two triangle case. So expect to see an ambiguous case on the mini quiz. Let's solve this triangle. I don't know B. I do know that A is 23 inches, C is 24 inches, and again, I have the side angle case where it is ambiguous, and I'm going to look for 0, 1, or 2 triangles. I know everything about A. I know a lot about C, but not everything, so I will set it up for sine of C. Okay, so sine, multiplying both sides by 24, sine of C will equal 24 sine of 85 over 23. Sine of C, just to look at what that number is, 1.039507511. Now I need to do the inverse of both sides. Angle C equals error. Why can't I do an inverse of this ratio? This ratio, which is opposite over hypotenuse, why can't I do an inverse on a ratio like that? Because the opposite must be shorter or equal to, shorter than the hypotenuse. Hypotenuse. So this would be a zero. No triangle can be formed in this manner. So if somebody told you to make a triangle with an 85-degree angle and take a ruler and use 24 and 23, in this setup, they would have no triangle. So we are done. Moving on to our two triangle case, which is going to be the one that you're going to see on your mini quiz. I want to caution you to do one triangle at a time, finish the whole triangle, then go back to the angle and use it as a reference angle, that first angle that you found, and use it as a reference angle. So let's start our triangle case. Okay, so we've got A, B, and C. Okay, this is in meters. This is another SSA, ambiguous. I can tell you right now that this will be the two triangle case, but we're going to look for 0, 1, or 2. It is going to be 2. So let's start with our angle C. So sine of C is equal to, over 9 is equal to the sine of A. I'm going to use the A relationship, 8. Sine of C will equal 9 times the sine of 20 over 8. And that's really degrees. Find out what we're getting for a ratio. The sine of C ratio, the opposite over hypotenuse, is 0.38477266612. Now we need to take the inverse sine of both sides, and this is where we get a reference angle that is going to be in quadrant 1, it will be the angle, but in quadrant 2, it will be the reference that I'll use to get that quadrant 2 angle. So my angle C, that is really a reference angle, is 22.6296. So this will be my reference that I'm going to use in both of my quadrants. So let's start with triangle 1. Making a grid to keep track of things. Triangle 1. Start off with angle C. The reference is the angle. I'm keeping it long just so that I have lots of decimals to use for my calculations. The angle that I don't know is angle B. But I do know angle A. And I just found angle C. Angle B is, let's see, 137.37. I will round that to 137 degrees. But I'll use the long number in my calculations for side B. And so side B over sine of the B, angle 137. Okay, there's my long angle. That will equal, and since I know everything about A, that will be the side relationship that I use. And so we get B is equal to, I'm just going to write it small, but like what I would have put into my calculator would have been much longer. Probably would have used the answer key. And that concludes my first of my two triangles. And let's just call this 22.6 degrees. There's my first triangle. Done. But now I have to do the second triangle. So this is triangle 2. Triangle 2 starts out with angle C, but equals 22.69296 as a reference angle. So angle C is actually in quadrant 2, referenced off of that angle. Angle C, I'll put a little prime on that to say that that's really the reference angle. Angle C is, let's see here, 157.37. So I will call angle C, I will call it 157 degrees, although I'm going to use the longer number when I do my calculations. So that was my calculation for angle C. That corresponds to that line. Now let's look at my calculation for angle B. It's going to correspond to this line, my angle B. It's going to look really similar. Angle B is going to be 180. See how that's the same? Minus 20 minus, now the 157 needs to come down. My angle B is going to be 2.6296, so let's call that 3 degrees. That's angle B. So we're calling that angle B. That's 3 degrees. Now let's find our side B. So notice that this is going to come down similar, but like what's going to be different about this? B over sine of, bring that angle down. I'll write it as the decimal. That's where the change is, because the rest stays the same. See how that's staying the same? Sine of 20 degrees, 8 over sine of 20. My side B will be and so my side B is 1.073. So let's call that 1.1 meters. And that is side B. So I have now solved all the pieces about my second triangle as well. There was a little more work to the first triangle, to the first angle, but you can see how those calculations line up and they look, the blue is exactly the same as what was there in the green for angle B, for side B, but that red item has to change as you're going along. Now my area. I think looking at this triangle, I would be best to use angle A because I have the most information about it. So it's going to be equal to BC sine of A. So 1/2 B is, let's see, B, we just found, oh, I should have done this for each triangle right away, 15.8, but I'll use like the long number, then it's the 9, sine of A, 20 degrees. You should get 24.4 meters squared. That's the area. And my over here, same exact setup for my area. I will do 1/2, but this time it's, as you know, continuing with the writing in red, the things that go in that are different. But notice how the 9 is the same and the sine of 20 is the same. So when I get that area, it's a really small area of 1.65 meters squared. And so that's the area of the second triangle. And that concludes law of sines. And so keep this 2 triangle case out and just don't get mixed up if I switch what's the first angle that you're doing the inverse of for angle C or angle B. Just make sure that that one is a reference angle in the second triangle and keep the rest of the calculations really similar. Whoops.